So there are a couple of more people standing in the back. I hope they come in. First of all, thanks a lot for joining the, I think it's the last talk, but it's not the least. It's not supposed to be the least important talk. Yes. So I hope you saved up some energy after 3 intense days of going through, I don't know, 450 slides with us in just under 60 minutes. But I think we'll be just all right. So to get started, this is Adam Spiers. Myself, I'm Dirk Mueller. We both work on the software engineering team for SUSE OpenStack Cloud. And over the years, we had made some experience in troubleshooting issues, sometimes caused by ourselves, sometimes caused by other factors. And for the next few minutes, we want to share some insights with you. So this is how marketing sells you OpenStack Cloud. It's all zip room. Not exactly sure what that's supposed to mean, but let's talk about it a little more about what is under the hood. So actually under the hood, as you know, there's a deployment framework. There's also OpenStack. OpenStack is a slightly complicated beast. So I measured again. So in the Cloud 7 release, it has internally over 3,000 parameters that have to be set right. In Cloud 7, we have more than 17 projects integrated that have to integrate very well with each other. And everything has to be mixed and matched perfectly well. Nevertheless, we have only 1 hour left. So for the troubleshooting, which basically means we have to try the impossible in giving you as much help as you can get in 1 hour. So in order to make that interactive, feel free to just interrupt and ask questions if you think something is going too fast or too slow, and we'll try to accommodate. Okay? Give you, wrong direction. To give you the overview, oh, this is bad. All right. Wow. So when you do deploy cloud, you typically deploy it over multiple nodes. The most important one, that's the one that you start with, is the admin node. That one is actually your deployment server for all the other nodes. So obviously it has, so I'm just going to read it out because it's probably very hard to read. So this is the repository mirror. On top of that, we're using Chef, which itself, the Chef server still uses RabbitMQ. On top of that, we have Clover, so both the Clover services and the Clover UI. So with Clover services, I mean everything that Clover needs to actually manage the nodes. And then once we have that part up, we have the control plane. Control plane usually runs on top of slash. It always runs on top of slash with HA. And on top of that, we have on the control plane, which is either the OpenStack control services or the network services, we have a couple of controllers and the message bus running as a server. And then all the rest is typically in the easiest example are either storage nodes or compute nodes. So one takeaway is that when you deploy SUSE OpenStack Cloud, everything actually runs on slash. That's the part that we can start with when we think about troubleshooting. Since all nodes are being installed with slash, you have a lot of troubleshooting hints and guides already available. There's a lot of good documentation about troubleshooting slash. We are just going to skip over that. The main things to watch out for typically are, well, watching out for hardware-related issues like some failing hard drives, failing memory, overheatings, things like that, failing paths to storage and similar things. Everything is going to syslog just as you are used to it on all the cloud-managed nodes, and you can. Well, to start troubleshooting, you can just check for the general health of the node. So you look at, I don't know, so typically one of the most frequently used commands for that is top. I guess you know about that. Other things are like VM start, uptime, PS3, just looking at what is running. how much memory is it, does it swapping, and so on. You look for core files, you can look for zombie processes just to get an idea on what's going on. Okay, so leave it at that with this less troubleshooting, which it's a bit outside the topic here. Let's take a look at the admin node. So the admin node is the first thing that we have to bring up here. I don't want to go into too much detail on that part either, because that's already covered pretty well by the deployment guide that you should be following and check for issues, because there's an FAQ in there. It has a lot of typical troubleshooting advice already documented in there. But just to summarize, installation log files of Clover by itself you can find under var log Clover install log. The actual messages from the running Clover services, the Clover UI and so on, can be found either under var log messages. So there you find log messages of the typical Clover daemons, like most importantly is like the DHCP daemon, most likely when you are having discovery issues, node discovery, node allocation issues. And the Clover log is actually under var log Clover production. There are actually two log files, it's var log production out and var log production.log. Both of them are pretty verbose and pretty intense in logging output, which is very helpful for us as engineers to understand when there is a problem, what exactly happened and how it led to the problem. The whole Chef and RabbitMQ layer has its own stack of log files. So RabbitMQ also uses in the background CouchDB. So CouchDB has its own log file, var log CouchDB. The Chef server has a log file, which is usually pretty sparse because we configure it by default without logging or with very minimal logging. So if there's something in there, then it's probably interesting. And if there are issues with installing the nodes, then it might be an issue with the way you have set up the repository mirroring on the admin node. So it's also helpful to figure out issues by looking at the repository mirror log. The repository mirror on the admin node is just run by regular Apache service. So and it logs to var log Apache provisional log. So there's an access log and an error log. Pretty typical setup. Obviously, the first one to look at is the error log. Again, this is the slide that probably should have been the first slide. Most importantly is that when you are hitting an issue, you are preserving the log files. Often enough, you might not even have time every time to troubleshoot it down to the root cause. But if you hit the same issue sometime later, it helps you to have log files of the previous incident available, because maybe you can find patterns, repeating patterns of what's going on when you're hitting an issue. So the general advice is, and don't wait for someone from the SUSE support team to ask you that first, do it always on your own, is to collect the support config. You should always run it on the admin node. And that's very important, because when you run it on the admin node, there's a plugin installed that we provide that collects a lot of essential information about the way you deployed your OpenStack Cloud installation. So it contains information about which services have been deployed where, how did you configure, which parameters did you use. And that's fairly essential for anyone else who wants to help you to understand what's actually going on. So there's a ton of useful information in there, like which networking model did you deploy, which networking layout did you choose, and so on. So that's absolutely mandatory. But we are also installing the necessary plugins on all the other nodes that are managed by SUSE OpenStack Cloud. So when you have already had a chance to isolate which node actually is affected or causing, in your opinion, the problem, then also feel free to run support config on that particular node, so just to capture the log files of that particular node as well. And in the case of HA, I think Adam is going to go into more detail and on that later. There are additional logging tools that you can choose for that greatly help you understand what's going on. All of that is also available from the UI. If you go to the Clover UI, there's under utilities, there's exported items. With that one, you can export a support config tarball. You can also export a dump of the chef database, so just so you know. Some general hints. It's always useful to have your authorized keys on the admin node pre-populated with keys that you want to have be propagated to other nodes. So everything that is in the authorized key file of the root account on the admin node will be also transferred to other nodes. Might help you with debugging in some ways. When you're facing issues with node discovery, the most useful log file is the one of the sledgehammer run, which is the run of the discovery image. And it can be found under varlog crowbar sledgehammer, and then the magic host name that is being generated whenever a host is being discovered. And also the syslog of an already installed node, so if you're beyond the discovery phase, the main syslog is also going to varlog nodes and the particular host name. So if you want to figure out which of my dozens of nodes that I have deployed, which one has the same error message that I'm seeing on the one that I am currently looking at. So one easy way to find that out is to go to the admin node and just grab through those log files, because all of them are in place. One more general thing about Crowbar is that there are two ways in which Crowbar is invoking chef runs on the nodes. So one way is when you actually go to the UI or use the command line to change a proposal. So you create a proposal, apply a proposal. That is one way how chef is being invoked. So that's a non-periodic run, so it's directly triggered. And in that case, the log files of those chef runs can be found under varlog crowbar chef client and then the host names. So one thing that most of us like to do is when we can repeat the problem by applying a varclamp, or like the application of a varclamp fails. In that case, we are doing tail-f on all those log files and press commit again and see what is happening at the same point in time. So you can see very nicely what is correlating in which order over multiple nodes and what's actually going on until the failure is happening. Other commands, I'm not going too much into details of those. So this is more like a reference slide deck for you when you want to look it up again. You can list nodes, you can forcefully transition nodes into a particular state. That will not actually do anything, it will just tell Crowbar that it's now in this state. So be a bit cautious with that. You can create, list, commit proposals, you can delete proposals. Two particularly helpful commands are when you have a proposal in applying state for whatever reason and it's stuck in there, so you had a particular issue, but you meanwhile resolve the issue, so you just want to tell Crowbar that the proposal is no longer applying, and you're actually sure that this is no longer the case, you can run Crowbar reset proposal on the particular proposal name. And what's that going to do is it's going to look for all proposals that are currently marked as being in applied state or in applying state and reset them back to ready state. You can also do the same afterwards for resetting the node. So if a node is stuck in an unhealthy state, you can put it back into an active state. So going more into the discovery issues again, typically nodes are deployed via PXE boot. You can, of course, also manually install nodes and then Crowbar register them. But in a discovery case, or in the PXE boot auto install case, you get a PXE Linux config file auto-generated for that particular MAC ID, so you can go look at that. There's an AutoIAS profile being generated automatically. You can also, for example, if you have issues with installing the node, what you can do, for example, you can edit that file. And for example, one thing that you can add is confirm config type true. That basically means that once the image is in installing state, and just before it starts installing, it will actually ask you to confirm to install. So by default, it would ultimately start to install and ultimately fail, and then you don't have any understanding of what's actually going on. So if you want to introspect what the Autodesk profile actually did on that node and why it's not properly doing, so one thing I often do is just setting the confirm flag to true, then restarting the installation, and then we'll actually stop before it does anything. So you can then interactively with your remote console go to the node and figure out what's happening there. All right. One more topic about discovery issues. If the node gets network actually in the discovery image, you're pretty good, because then from the admin node you can SSH to the node and figure out what's going on. If the node doesn't get network, then you're a bit in trouble, because you need to have some other way of accessing the node in order to figure out what's going on, because you're also obviously not getting any log files sent back to the admin node, because that's going over the network, obviously. So one particular hint is that you can set in the raw mode of the provisioner proposal, you can set a password for the discovery image. So it's this particular key. You have to append it to the command to the kernel command line. So it's append the discovery root equals my password, whatever my password is. And if you reboot with that discovery image, then you can log in from zero or from local console to that node and figure out what's going on there. There are some hidden settings that make debugging or troubleshooting a lot easier. So the two that I want to point out is almost every backend has a debug flag and a verbose flag. The verbose flag is typically defaulting to true, so you don't actually have to change it. But the debug flag is defaulting to false, so you want to turn that particular debug to true before looking at it in more detail. Okay. Sorry? Okay. It should automatically reload, I guess. Anyway.
Maybe just quick presentation and start.
Oh, thanks. Cool. Live editing of slides. That's high availability. Okay, so coming back to other nodes, every other node, all of them are more or less getting a chef management layer deployed on initial deployment. So independently of what's actually running on top of that, whether it's a control node or a storage or compute node, all of them are getting a chef client installed. The chef client is set to periodic runs. And you can introspect the log files of the periodic runs under varlog chef client log on that particular node. You can also check whether the chef client is still running. So if a node is turning gray, for example, or red in the Clover UI, then these are the two things to look at first. Another thing that's particularly important is that you can ask Clover to rejoin a node. So if a node is in a problem state, and you think you fixed the problem, you can run Clover join -- start, maybe even with a verbose option. And then in that case, you can see what would happen if the node would be rebooted. So in case you have a node that is in a red state, most people just reboot a node and figure out whether it's recovering. This is usually a quicker way when you know what the problem was and the problem is solved. One important thing is that if it's a node that is in an HA cluster, you typically want to run that on the founder node first. Okay. One particular topic that is typically the troubleshooting number one is networking. So networking in Clover, as you know, is managed by a network.json file that is being imported as data into the network bar clamp. And that part is often fairly tricky to get right, especially if you have not really homogeneous hardware, but you have different hardware. So I'm just going to show you a very quick example of how to manage exceptions if you have like one node that is dissimilar from other nodes. Just to give you an intro, over each of the physical devices that every node has, Clover actually does an abstraction. So you refer to interfaces not by their name, but by their speed identifier. So there's a fairly sophisticated naming scheme for giving a name to an interface, and that's not unique. So there are multiple names that can refer in a particular case to the same interface, and that's perfectly fine. So in the case of plus 10 G1, that basically means it's the first 10 gig or better interface available on the node. In general, those interfaces can be combined. So there's yet another abstraction on top. That's the conduit. So conduits can combine one or more interfaces. And on top of the conduits, you can actually define your networks. So as I explained, for example, if you have a node that has 3 10 gig network cards, then this one and that one potentially might refer to the same. What's happening, there's an internal prioritization, so it will actually predictably choose the order of the network cards. But in some cases, that might be part of your problem. The ordering, like this predictable sorting of interfaces, is by default done just by alphabetically sorting of the links in that directory, so /sys class net. So this one contains all the links to all network cards that the kernel found. And however, that is not fixed. So you can use the interface map, which is a section in the network JSON, for changing that. And you can create a custom map for a particular node if the cabling is different. And that way you can override a particular mapping for one particular node. So one interface map example is this one. So for a particular machine with a very specific serial number, we are defining a different bus order than a normal one. Or we can also do for a particular machine name, like if you have a lot of machines from a particular vendor, you can define an override that matches for all of those machines. One slide pre-announcement for Cloud 7 and newer. We added 2 command line tools that makes this tremendously easier than it was before. So there's a network JSON resolve tool that you can give a network JSON, like a local copy, and then it has a ton of subcommands that are really useful for understanding how would it actually allocate the networks on that particular machine. So you can, on the admin node, take a look, okay, how is it actually mapping for that particular other node that is very far away, but that has already been discovered by the admin node. You can look at how would it actually map. And then you can go in, edit your network JSON, change some parameters, change the mappings, change the ordering, and see how it would affect the system without actually deploying it. And then once you're happy with this result, you can directly load the network JSON that you have prepared that way and not run into the issues that you had like before with trying to figure out how to make the network JSON right without reinstalling all the time. So very quick cheat sheet that is mostly for reference. You can figure out the name of a machine, you can figure out the serial number with that particular command. These are the default orders. So the identifiers is more or less the part where the symlink is pointing to, so that PCI strings or those 2 parameters, that's the identifier for the interface map. And that way you can generate your own entry, and with the resolve tool you can pre-test the entry whether it's actually making any difference. Okay, so now that we got the networking right, let's go quickly over OpenStack, and I apologize, since I now reloaded the application, I don't know how much time I have left. This is the scary diagram that you get when someone asks you how OpenStack works and wants to scare you off. It's not very useful. I like this diagram more because it gives you some structure of how components are interacting with each other. So in general, OpenStack projects are very much alike. So all of them have, it's RESTful services, service architecture. So all of them have some API service. Usually, I don't recall anyone that doesn't have at least one extra service that does the actual work. So you have a front end that handles the API and that is connected via the message bus to one or more backend services, depending on which project we are talking about. Typically, there's the OpenStack client that we by default install on all the control nodes. And that one automatically discovers the installed services. So you can run OpenStack help, you can run list, and you see directly which services are available in that OpenStack installation and introspect the services that way. Sometimes there is a project codename -manage command that you can run as an admin user, and that gives you additional insights into the underlying functionality or the underlying health state of a service. So if you're looking for troubleshooting a particular service, look for this -manage command. It's somewhat deprecated, so they are slowly removing that in newer releases, but if it's still there, it usually has very helpful functionality. One quick comment about the way we package OpenStack. So we try to make it very, very consistent. So all the packages are named starting with OpenStack. Then we use the project code name, so keystone for the identity service and so on. We typically create a subpackage for every service. So just by listing the installed packages, you see what particular services you might have available on that particular machine. And unless it's an HA cluster, you can just query those services and there's a health state just like normal with systemd. Also important to know, typically verbose is enabled, so you will see traceback in the log files of OpenStack. In cases where verbose is disabled, you will not find them, which is very unuseful for troubleshooting, so you want to have verbose always enabled. On the other side, you have to have debug enabled because only then you get the actual underlying reason or any details logged about those reasons in the log files of the service. So for example, if you have an authentication error or if you get some error message from the API when one other service is interacting with that API, you typically don't get the useful error message to the client. So instead, the useful error message that helps you pinpointing the issue is only in the server log for security reasons. And typically, it's not logged unless debug is turned on. Debug can be very, very verbose. So don't leave it running unattended if you don't have the disk space. And of course, in general, if you have error messages, you know we are just shipping OpenStack. So every vendor has more or less the same OpenStack features and bugs. So you typically find very quickly help by searching for particular error messages on like ask OpenStack.org or the documentation that is upstream available. I'm just going to skip over that part. The first thing I would always want to do for troubleshooting an OpenStack installation where I have absolutely no idea what's going on is to log into the dashboard. Because if I can log into the dashboard, I know that at least most of the things that I need for basic functioning are there. If I cannot log in there, then on the dashboard node, you can look into the Apache log file. The particular interesting one is the OpenStack dashboard error log. Search for error messages or messages in there that contain the word traceback or error. That's typically pointing to a fatal problem. So that's the first thing that you want to search for. These are some examples like that. You can find a connection error. Also, the next thing, which is very easy before even starting to think about what could be the problem, is you log in. When you are able to log in, go to the project tab and you click through all the tabs. Just plain click through all of them. And whenever there's an error message popping up in the upper right corner, I mean, it takes you maybe 30 seconds and you immediately know exactly which service has a problem, where's the part where you have to start digging for problems. Because what the dashboard does when you click on them, it just tries to interact with that particular service and tries to fetch some data, show you something. And when that fails, you get an error message and you know exactly where to start looking. And also it's ordered somehow by complexity. So the easier services are on the top and the more complex are at the bottom. So if you go in by order, you find the lowest level that has a problem. Also, of course, don't forget to enable debug if you think the problem is in Horizon by itself. One more general hint: if you have identity or keystone issues, which is probably prevalent if you use some integration with some LDAP or Active Directory, you will find tons of weird problems if your identity service isn't working properly. So first thing is to get that right. So you use with the admin user and with other users, you run OpenStack token issue, which basically verifies that the credentials that you have provided are working properly, so that everything is going to the right identity backend, and the identity backend is either approving or disapproving your request. And that way you can very quickly isolate already issues. On the imaging service, I typically also try to not only list images, which is the first thing to do to see if the service is actually still alive. I also try to download an image and list an image, because that's accessing two different parts of the service. And sometimes the problem is actually visible in the service, but it's actually not caused by the service. So for example, the image that it tries to provide to someone is no longer there because the backend storage was or is malfunctioning. And you wouldn't see it by just listing, so you actually have to just try fetching the image. And if you do it to def null, it doesn't hurt. You just see error message. If you don't see error message, you know where to start looking. Also, typical thing that people forget in the beginning is always tag your images with properties, especially if you have multiple architectures, have multiple hypervisors in your cloud. Always set the hypervisor property, always set the architecture. Also set the image size. The image size is important to avoid that a user chooses a flavor that is too small. And I mean, you are ironing out like 50% of the beginner problems by just setting the image size properly. Okay. How are we doing time-wise? Okay. So the typical problem people have is, or the typical request that arrives at an admin desk is, my VM doesn't boot. There could be 5,000 reasons for that, and it would take more than an hour to iterate through all of them. But what is helpful is to have an understanding of the big picture. So this is one of the pictures that I stole from the upstream documentation. It shows you in which order requests are going through Nova and interacting services. So you can see the main request from the dashboard when you start an instance is actually going to the Nova API. But even before it hits the Nova API, there's already Keystone involved before checking the authentication. Then the request goes into a queue, and then there are services behind Nova that are actually handling those requests in a row. And as part of handling those requests, it interacts with many of the other core services. So it interacts with Cinder for creating or allocating volumes. It interacts with Neutron for creating network ports and transferring, and it interacts with the image store for actually setting up the initial boot image. So the typical issues that we have with scheduling is that it cannot find a host. The typical problem is that the image keeps in scheduled state and for a significant amount of time, and after some time it goes into an error state. And that typically indicates that there was some issue in trying to find a host that would match the image. So it's important to understand at least roughly how the determination of the compute host works. And it's actually a pretty natural workflow. So over all the hosts, compute hosts in that case, that are available, the first thing that happens is that it applies a set of configured filters. And those filters are, depending on the request of the node, are automatically already discarding some of the hosts. For example, they don't have the matching architecture, they don't have enough disk space available for that particular request, or they're disqualified for some other reasons. Like, for example, they have recently failed to schedule a similar request in before. So there are also some more advanced filters. So from the remaining list of hosts, it actually does just the sorting. So there's a second round of filtering or waiting prioritization going on. And then it tries the sorted list afterwards in order. So what you typically see when you go to the dashboard on an instance failure, you see the error message of the last host. Might not be the most relevant problem, because typically you want to find the error message of the first host that failed, because that's the one that it would prefer to go to. So when you're hitting that issue, or when you're hitting the issue that in general scheduling of VMs is slow, you want to actually look through the result, and that you can find that in the Nova scheduler log of the prioritized list of hosts that it will try, and you can see there the order of the nodes and with which error message each of them failed. Because the last error message might not be the same one like the first one, and you want to fix the first one as well. Okay, timing-wise, I'm going to skip a bit forward. For Cinder, the service is actually pretty similar to Nova, so it works exactly the same way. It has, instead of compute resources, it has volume hosts. So if you go in the admin tab under volumes, you can find for each particular volume, you can find a host that is actually hosting or providing that particular volume to VMs. And if you have issues with one particular volume, obviously the first thing to do is to figure out which host is actually providing the underlying service of that volume to the VMs, and you go look there. A couple of more topics about Neutron. In the Neutron case, we have the services distributed over all of the nodes. So whenever there's a networking issue with OpenStack, it's actually fairly difficult to figure out which node is actually the causing the issue primarily. So what it helps you to find and to pinpoint the cause is to understand roughly how the services are being laid out and how they are interacting. So in a very simplified case, like no DVR router, no HA involved, there's just a network node. You're familiar with that. The network node runs the DHCP agent. Actually, every node runs the L2 agent, and that's usually not causing a problem. And the network node is running the L3 agent. So that's the node that is doing the routing of individual tenant-defined networks. So here we have 4 different networks defined by color. And it also provides the metadata agent, which is responsible for providing the network information or additional information to Cloud Init when an instance is booting. So compared to that with DVR, the services of the L3 agent are actually distributed across all the nodes. So it's distributed across the network nodes, and it's distributed across the compute nodes. So it's important to understand in that case which network is actually affected currently by the problem that I'm trying to debug, because not all the nodes are involved in all of the networks. So in this particular example, there's a network that is not allocated on compute 1 because there's no VM attached on that particular node, so it's not available on the L3 agent that is running on that node, for example. So going away from the DVR setup case and taking a look at this one extra slide. Taking a look at the HA setup. In that case, the layout of the services is completely different, or different. In the HA case, the compute node actually does not run any extra L3 services. So the DHCP agent and the L3 agent is spread across the network nodes. And here the setup is by itself active-active. So if you have multiple networks, then all of them go to a different particular network node. However, what happens when you think about like one node is failing in the network setup, like for example, here, let's assume the left one is failing. In this case, the HA services will take care to move the no longer active available routing services of those networks that were only hosted by that particular node that just failed, move over to some other network node. So one easy thing to remember. If you want to trace the packet flow, and eventually you have to do that, it's extremely helpful to understand how it would normally actually look like. The only thing, I don't want to explain it in too much detail, but the thing I want to point out, there's a really, really good upstream documentation about going into way too much detail on how the networking is being set up by OpenStack. So if you're hitting a particular network issue, you will eventually open that web page and just compare, okay, I see a packet at that point in time, but I don't see it at that point in time. So that way you are narrowing down where in the packet workflow which it's supposed to happen, where it's actually getting stuck. And that's a tedious job, but you eventually don't get around doing it. To summarize, this is the reference slide. Depending on how the network is being configured, whether it's a DVR network or non-DVR network, you can search for packets and where they might get lost in a particular order. So you typically want to search on the network node for SNAT traffic or for DHCP traffic that is getting lost. So you want to TCP dump on the network node and see if requests are coming up there, if a request is not arriving there. In the DVR case, the floating IPs are handled directly on the compute node. That's one important thing to remember. So in that case, there's an accessibility or network traffic issue from the outside to the VM. You want to look directly on the compute node. Okay. So now I confused you all out of you for OpenStack. I'm actually going to hand over to Adam, who is going to go into the high availability details.
Okay. Still awake? Let's see if I can come around here. Oh, okay, transitions. All right. So on the high availability side, I think that we don't have time to go into all the details. I mean, it's just not possible in 1 hour, as Dirk said. But I think the important things to understand are really the architecture of how everything fits together in terms of the clustering technology and how that interacts with SUSE OpenStack Cloud, and then to know where to look when things go wrong. So with regard to the first point of understanding the architecture, this is the architecture of how SUSE OpenStack Cloud deploys the HA part of the technology. So we have the admin server that Dirk already mentioned with the crowbar running on it, and that uses Chef on the cluster nodes. So that is on the controller nodes, which get set up as a cluster. And if you're also doing compute HA, then this also applies to the compute nodes. That we have Chef client running on those cluster nodes, and that does all the configuration, which includes things like installing the packages that set up the clustering technology and then configuring it. You don't need to know the details of all this, but basically, Chef client uses some chef cookbooks on the top right there, and then that, through a bunch of code, talks to CRM, which is the interface to the pacemaker cluster, and that talks to the daemon, and that talks to the messaging layer, which communicates with the other nodes in the cluster. So taking a closer look quickly at the clustering technology itself, as you probably know, it's pacemaker. Again, I'm not going to go into detail on all of this. The most important things to know from a troubleshooting point of view are you've got the messaging layer at the bottom, which is the way that the cluster nodes talk to each other. That's CoreSync. And then you have each cluster node is responsible for running services locally on it, which it does through the local resource manager, or LRM for short. And that talks to it controls the resources on the cluster through a resource agent, which I'll explain shortly. The other important thing to understand, and this is quite important in terms of understanding which logs to look at, is that at any one time in the cluster, there is one node which is the designated controller. That gets determined by election, and the reason, and that can move around. If that node dies, then there's an election, and another node becomes the new designated coordinator. And that affects which node you need to look at for the log files to understand the policy engine when pacemaker is making decisions about where to run things. So the resource agents I mentioned is the glue between pacemaker and the resources that it controls. They can be systemd services as normal old style sys5 init LSB init scripts, or sometimes they can be OCF resource agents, and they live in this path here, and that is they're all just bash scripts, so it's actually quite easy to debug those. You can just add a -x to the top of the bash scripts or something like that if you want to understand more about what they're doing. So before you leap into diagnosing a problem, really having some context is very important. And one nice tool for this is if you type CRM configure graph on any node in the cluster, then you get something like this. It didn't fit on the screen, but you just see all the resources in the cluster, and you see how they depend on each other in the order that they'll start and stop. So that's quite a nice debugging tool for understanding the cluster config. In addition to that, you have the CRM Mon, which is a bit like top for the cluster, just seeing what resources are running, where they're running. So obviously that's useful to know before leaping into debugging, but also it's really helpful to understand what fencing devices you have set up, how the network looks, and particularly what was done leading up to the failure. It's very common that I get people contacting me and saying, oh, there's a problem with my cluster, please can you tell me what's gone wrong, and they'll give me the support configs and maybe an HB report, but they won't tell me what they did to trigger the problem, and that information is usually really valuable when trying to debug. And even if it happened without somebody doing something to break it, if it sort of broke apparently by itself, it's really important to look for the first sign of something going wrong, because things can sometimes cascade. So when you start diagnosing, you really have to firstly determine what was the scope of the problem. Was it a problem on an individual resource, on a whole node, or was it some kind of synchronization issue with the way that Crowbar and Chef Client interact with the cluster? Or maybe it was actually a bug in the cluster software itself. Thankfully, that's very rare. It's really solid software, but it can happen occasionally. So the first thing to determine is which aspect of the whole setup was affected first. And the Chef Client logs, which I'll flash up a slide on in a bit, giving the location of those. That is typically a good place to start, but not always. So actually, I think I just, can I just reload this? Because I just tweaked it slightly. There we go. Perfect, thanks. Yeah, so just setting some expectations. Obviously, if there are hardware failures, then or there are failures outside the cluster, external storage, maybe something in your connection to the Ceph storage cluster went wrong, or whatever, then obviously failures are expected in those cases. in normal operation, if you're just using Crowbar in the normal way or using OpenStack in the normal way, you shouldn't expect failures. So if you see them, then something has gone wrong, and it could well be a bug. This is how, once a failure happens and pacemaker retries and it hits the failure threshold, it will give up retrying. At that point, you will see an error, and you can tell pacemaker to clean up the error and just resume normal operations, but don't get in the habit of doing that just as a reaction to some bug or some failure that just keeps coming back and you don't understand why. If it keeps coming back, then it probably is a bug. So what do resource failures in particular look like? Well, there's an example. Obviously, services become available. You know, if it's a failure with Horizon, then you might not be able to connect to the dashboard, although hopefully the load balancer will redirect you to another working resource on the back end. So, but it's pretty obvious, I think, when a resource fails. If it's active passive, then it will migrate to another node. If a whole node goes down or something goes wrong with it, but it doesn't go down, then pacemaker might decide the safest thing to do is to kill it with Stoneth, shoot the other node in the head, or fencing, as it's also known. And obviously, in that case, if the node has died for whatever reason, then things like SSH connections to the Hawk web interface will die. So that's one thing. If you're SSH to a node and suddenly you lose the connection, that might be a hint that it's getting fenced for some reason, and you need to figure out why. There can be orchestration failures because when we're setting up things on the cluster, things have to be done in the right order. And it gets quite complicated, and we have a mechanism in Crowbar and Chef for doing that, which are these synchronization marks. There are different types of synchronization marks. I don't really have time to go into that now. But basically, if you see an error that says a node timed out waiting for a synchronization mark, and you're thinking, what's the problem here? That probably means you're looking at the wrong log file on the wrong node, because that node was waiting for something to happen on another node, and you need to go to that other node that it was waiting for and figure out what went wrong there. And this is a tip for how to find out, because usually nodes generally wait for one node, which we call the founder node. It's like the first node in the cluster. So it's normally the founder node that you want to look at. Here are the logs. So you've got the Chef client logs. When you're applying a proposal, there you need to look. The log files for that are maybe counterintuitively fed back to the admin node, so you need to look at varlog crowbar Chef client. But in addition to that, there's this periodic run every 15 minutes, and so if Chef client fails during one of those periodic runs, then you actually look on the node itself that was running Chef client, and it's under varlog Chef client log. Actually, I would say that this is probably one of the most important slides in the whole deck, because understanding the difference between those two sets of log files is really crucial for knowing where to look. And then for all the cluster stack, it logs to varlog messages and varlog pacemaker.log. There's more detail in varlog pacemaker.log, so sometimes you need to look there. None of the pacemaker stuff goes back to the admin node. So yeah, I mentioned earlier the DC, the designated controller, and that is the log files for that node contain the most information about what the cluster's deciding to do in any particular transition between two states. And actually, I think that the best way to really look into all of this, if you really need to look into the details of what's going on within the cluster, I would strongly recommend using Hawk, and hopefully I can just switch to that here, or do I have to escape this first? How do I switch to the... Yep. That's it, yeah. So this is actually a live running instance of the Hawk web interface, and if I can find the mouse, there it is. So hopefully the VPN is still up and running. Is it connected to the wireless? Yeah. Oh, okay, great. Yeah, so this is a really nice view of the whole cluster. So we can see we've got all these resources. So if it's only running, so the first column is one of the controllers and the second column is another of the controllers. So things like Rabbit here we see is active passive because it's only started on one node, not the other node. If there's a green box for each node, then we know it's an active thing. It's running on both nodes at the same time. These colors are for the master-slave resources for DRBD. So the data is on the master. Its reads and writes go to the master, and if that fails, then the slave gets promoted to master and takes over. And in the meantime, all data is replicated from the master to the slave to keep it up to date. Then the third and fourth columns, in this case, we have compute node HA enabled, so Nova Compute are actually being managed by Pacemaker. So that's a really nice thing. There's lots of different other views you can get in there. Did I click that? Yeah. Okay. Yeah, it's a bit of a low resolution to see that, but the nicest thing for debugging is you can generate a History Explorer report for a given period, and here's one we generated earlier, and it loads the report, and then you get this visualization of the timeline of cluster transitions. Each transition is a state in the cluster where things started or stopped, or maybe a node got fenced. So each one of these dots is a transition, and you can click on a transition, and then you can actually see what was the state at that particular point. You can look at get a diff of the before and after. That's maybe not a good example because not much changed apparently. But yeah, it's fun to play around with that, and it's a much quicker way of understanding what's going on in the cluster than doing it through the command line in general. Not always, but in general. So I would definitely recommend. Thank you. Okay, we're running out of time. So this slide deck, you know, obviously you can have access to and use it as a reference. I mean, there's tons of information in there, and there's far more than we could cover in an hour, or you could remember in an hour, absorb and remember. But just as a reference, you know, there are some examples of things like messages in the logs that when things are going wrong and when they're going right and what they look like. Unfortunately, Pacemaker is not the easiest thing to understand from the log messages. They can be very technical and a bit cryptic. So practice makes perfect on that. Yeah. Quick tips on stabilizing and recovering a cluster if something's gone really badly wrong, which is very rare, but it can happen. Then you basically need to just get it down to a single node that's functioning stably, and then just gradually add things back in. So that's just guiding you through the process of that. You can read the slides if you want to know the details after. And this is another handy trick if you want to debug active services, and you want to actually do maybe some traffic sniffing and packet dump analysis on a particular node. For example, if you want to look at Horizon's traffic, then you can add a location constraint to the cluster that forces it to only run on one node. And then even though you've got the load balancer, the HA proxy load balancer in front, you can just have the traffic going through one node, and then you can trace requests. I think we can, well, this is probably a decent last slide. This is like the 4-line cheat sheet to HA. CRM configure show will give you the configuration of the whole cluster. CRM Mon, as I already mentioned, is like the top for the cluster, and you can restart resources like that and clean them up like that. So I think we should, do you think maybe open for questions at this point?
Is this set of slides going to end up on the conference line?
Yeah, well, yeah.
Any other third-party tools that do diagnostics in like the SUSE Volumes?
I think you mean for OpenStack. I think there are. Well, there definitely are. I mean, there are logging solutions and like elk kind of stacks that will suck all the OpenStack logs into a central system, and then you can perform analysis and correlation on that. I'm not sure if do we partner with anybody on
Yeah. So one thing that we are covering that has been announced, I think, yesterday is the partnership with Fujitsu. So we're looking at integrating their cloud monitoring manager into the game, which is in the backend. It's a lot of additions over basically OpenStack Monaska, if that's something that you are familiar with logging and analyzing tool. So that's definitely one huge improvement over these manual steps that we went through here.
Anything else? If you go away remembering one thing, it's when something goes wrong, take a support config straight away. And if it's an HA-related thing, take an HB report. And that's probably the most. Would you agree? One of the most important things, because that really, especially if you're interacting with SUSE for support, that is a huge help. But even if you want to, in a situation of debugging it yourself in the early stages, just having that initial capture, because if a problem occurs and then you're playing around with things to try and figure out what went wrong, and maybe you try cleaning up and stuff, then of course those extra steps you're taking there are generating new log messages and new changes in the whole thing. And if you haven't captured a snapshot just of the state of the cluster or the nodes immediately after the problem, then it can be confusing sometimes to distinguish between what was the original problem and what was experimentation that happened afterwards. But certainly for collaborative debugging, the support config always on the admin node and always on the affected node if it was another node where the problem was occurred, or multiple nodes. Basically just take as many support configs as you can.
Maybe we should automate that, actually.
Yeah, maybe we should.
Room for future improvement.
Yeah.
Right.
All right. Thanks very much.